Let's jump right into a fascinating breakdown of some recent technical writing. We're looking at a developer named Ang, specifically Notes-on-Haskell-Programming, Part 168. Now, even though this is about Haskell, don't tune out if you write in Python or JavaScript, because the core concepts here, they apply to literally anyone writing, reading, or maintaining code. We are going to explore this journey of taking code that, technically works and transforming it into code that actually communicates to human beings. And that brings us to this incredibly honest quote from Ang. Ang was working on this string replacement issue, right? Put in the work, nailed the logic, and the bug was fixed. The compiler is perfectly happy, but, Ang writes, the generated code is not readable for my taste. We have all been there. You spend hours on a problem, the tests finally turn green, but you step back and look at your screen, and it is just an aesthetic nightmare. It's this massive wall of text over a fact you won't understand in 2 weeks. That's the exact dilemma Ang faced, and honestly, it's the perfect jumping-off point for a masterclass in refactoring. Section 1, the readability dilemma. We're looking at why code that just mechanically works isn't always enough to save you from technical debt. Moving right along to Section 2, the refactoring toolkit. Let's see what specific structural tools Ang pulled out to clean up this mess. Just look at the stark contrast between these two styles. The old approach relies on deeply nested let-in blocks. It's like a giant puzzle. It forces your core logic to get completely buried under layers of local variables. Your eyes are constantly darting back and forth, just trying to figure out what belongs where. But check out Ang's new approach. By moving the helper functions down into a where block at the bottom, the absolute most important, high-level logic stays right at the top where you can easily see it. All that extra noise is pushed down and out of the way. It is a massive win for visual clarity. So how exactly did Ang pull this off? Well, it wasn't just randomly shuffling lines around. It was a very precise 3-step process. Step 1, yank out those hidden intermediate variables. Those placeholders just add mental clutter, so they had to go. Step 2, shift over to multiple fold vol calls, which basically restructures how the data gets processed. And step 3, replace inline-lambdas with semantic names. That last step is absolutely crucial because it shifts the focus from how the computer is doing something to what the human intent actually is. Let's zoom in on step 2 for a second. If you aren't familiar, Ang quickly demystifies fold L for us. Think of it effectively as a for loop in Haskell. It's just a clean, predictable way to iterate over a collection and build up a result. By refactoring to use multiple fold L calls, Ang was setting up much cleaner iteration loops to handle all that string replacement logic. Okay, Section 3, semantic functions. Now we shift our focus from just structural cleanup to the actual polish phase. This is where the magic really happens. Ang ditched those generic inline lambdas. Instead of making you, the reader, mentally decode anonymous blocks of logic on the fly, Ang extracted them into local functions with highly specific semantic names. We're talking names like hide keyword and swap keyword. Boom, you instantly know exactly what the code is doing without having to parse the raw mechanics. It's a real game changer that drastically lowers the cognitive load for anyone reading it. And here is the ultimate payoff of bringing all these techniques together. Because Ang stripped out the intermediate variables, used clear iteration, and gave those helper functions semantic names, the main logic remains entirely lean in the function body. If a brand new developer opens this file today, they get a high-level summary immediately. It basically reads like plain English. If they need to dig into the weeds of how hide keyword works, sure, they can scroll down to that where block we talked about earlier, but to just grasp the overall flow, that lean function body gives it to them instantly. Finally, Section 4, the pursuit of perfection. Let's zoom out and look at the big picture of code craftsmanship here. Ang wraps up the notes with a really grounded, honest thought. Are there ways to improve this? Probably, but so far, this is probably the best we can refactor now. I love that, because after all that hard work, the structural shifts, the naming, the polishing, Ang admits it still might not be flawless. It's a great reminder that refactoring is an ongoing pursuit. It's not a final destination. You refactor until the code is clear, until it's lean, and until it tells the right story. But at a certain point, you have to know when to stop and ship it. It's the best we can do right now, and hey, tomorrow, with fresh eyes and more context, we might make it even better. So, what does this all mean for us? It leaves us with a fascinating question to ponder. When is code truly finished? As Ang's notes beautifully illustrate, perfect code is completely subjective. It's an ongoing, evolving conversation between you, the machine, and the developers who will come after you. By prioritizing readability, leaning on structural tools like where blocks, and using semantic, meaningful names, you ensure that conversation is a pleasant one. So the next time you write a block of code that technically works, ask yourself, is this readable for my taste?